And we're live again. Welcome back, everybody. Apologies for the technical difficulties here. I'm just going to start where I left off, which is with the demonstration of Earth Engine in the online code editor at code.earthengine.google.com. So I'm just going to share my screen here, and I hope you can see that. And this is just the tail end of this demonstration, of the presentation. We can send you the link later, so you'll have all these slides. But please do sign up for Earth Engine. So here's the sign up. It's free for academic and non-commercial use. Here are the docs, and I'll show you where to get those docs in a second. But for now, we're going to be using the online code editor at code.earthengine.google.com. So here's the code editor just running inside a Chrome browser. And let me just give you a brief tour of this thing. First of all, this is the scripts tab. This is just a Git repository that is hosted at Google. And so if you save a script, it ends up in this little Git repository. It's private to you. We can't read it. No one else can. But you can share these repositories if you want to share them with your friends and colleagues and collaborators. The other thing I'd like to point out here are the example scripts. So previously we're talking about images and features. Here are lots of examples for how to use images and image collections. So there's some compositing stuff in there. There's feature collection stuff, charts, arrays, primitives, a bunch of cloud masking examples, code editor examples, and user interface examples. So this is a great way to look at code to help you get started. This is the Docs tab. So here's the complete API reference. So previously we were talking about reducers. Here are all the reducers, including counting reducers and mean, median, min, max, standard deviation, and variance, in addition to more complicated things like histograms and linear regression. This is all implemented in the reducer package, where reducers are just the kind of statistic that you want to compute. Assets. So if you save something, it will end up in your personal assets folder. So here's my personal assets folder. It's called Users and Clinton. It will ask you to choose this name when you sign up and start using Earth Engine. So please choose a good name for your personal folder. You know, something based on your username or something of that nature, because it will be very hard to change this later. So please choose a good name. And you can upload stuff here. So if I click the new button, here's where you can upload a shapefile. You can upload an image as a geotiff. You can upload a table as a shapefile. And when you do that, it ends up in this little folder that we give you. You have 250 gigabytes of free storage in here. And these are private to you. Again, we can't see them, no one can, but you can share them if you want, or you can import them directly to your script from here. So on the right side is the inspector, so you can click on the map and see a location, and if there are images added to the map or features, you'll see the pixel value as well. I'll show you how to do that in a second. This is where messages come. So here I'm just running kind of a silly hello world example. And again, this is the JavaScript part of the code editor. So you type JavaScript here, and then I click the run button, and it prints into the console. Tasks are where you execute long running tasks. So when you do an export, and you can find the export docs here in the docs tab. So here's export image. And you can export an image to an asset, meaning it goes to your assets folder, or you can export it to a cloud storage bucket or to your Drive account and download it from there. So anything that you can find in the Earth Engine catalog, you can export. Anything you make from what you find in Earth Engine, you can export that as well. You can export images or maps, a set of map tiles for display in the Maps API or Earth. You can export tables as a CSV or shapefile, and you can also even make little videos. So for example, you can make your own time lapse based on data that you create in here. Here's the map interface. You can pan, you can zoom, I already demonstrated finding a place, which is, for example, Kampala. I've never been here, but I've heard it's very nice. And so there's finding a place. You can also draw things. So these are all geometry drawing tools. So I can just drop a point here if I want to, and then that will come into your imports. So here's that point that I just dropped on the map, and you can move this thing around and make points, lines, and areas interactively this way. As I mentioned previously, I wanted to demonstrate searching in the data catalog. So if I just search for something, for example, I can search for Landsat 8. And here are a whole variety of Landsat 8 data collections. And I can click more, and you can find a ton of Landsat stuff. But all I really want are these raw scenes. So for those of you familiar with Landsat, it's organized into collections, and each collection has tiers. Tier 1 is the good stuff, meaning that it's all been properly calibrated and georeferenced. And if I click the import button, first of all, you'll note that if I click on the thing, it will give you a data set description, which is describing the bands that you will find in each image in this collection. And in addition, the metadata properties that you'll find on each image in the collection. And this can be useful for sorting and joining and so on and so forth. Also note this import button here. So if I just click the import button, it will make a new variable in my script in this imports section called image collection. So my point is called geometry by default, but I can rename this stuff just by clicking on it. So I can, I'll just name that Landsat 8 raw because that's what it is. It's these raw scenes here. And now I'd like to do something with this. So again, this is the entire collection of Landsat 8 raw scenes from all over the world. But I can do something like make a simple composite out of them. And I'm going to do that by calling a special algorithm called simple composite. So I'm going to type, let me see if I can talk and type at the same time. I'm not very good at that. ee.algorithms.landsat.simple composite. And if I just open paren and press Control Space, this will not only fill in the list of parameters for you, but it will also give you a little description of how this thing works. So let me just show you that again. I will take that away. I can press Control Space here, or I can just look in the docs. So here are the docs. Here's ee.algorithms. Here is ee.algorithms.landsat. Here is simple composite. And if I click this, it will explain what this thing is doing. Specifically, it's creating a Landsat top of atmosphere reflectance composite from a collection of raw scenes. And you can read more details about that later, and you can read what the parameters are here. But suffice it to say, what I want to do, I'm just going to type Control Space, get this list of parameters, open curly bracket, and now I can start filling in the parameters here. So this is the collection parameter, and the argument that I want for that is this Landsat 8 raw scene. So I'm just going to paste this Landsat 8 raw scene in there. Percentile is the 50th percentile, or the median by default. And never mind this stuff, you can fiddle with that if you want, but I just want it to be a float collection that comes out the or a float image that comes out the other end. And that is it. That is will be a relatively cloud-free Landsat composite, and we can visualize it by calling capital MAP map. So here is the capital MAP map docs. You can see all the things that you can do on the map here. That capital MAP map is this thing here. So I'm just telling that thing there to add a layer. And the layer I want to add is the composite. And